Hello, my name is Maxim Chepelev, and in this presentation we will discuss price linkages and taxes in the multi-region model. So we will start this presentation by discussing the definition of the price linkages, then we'll move to the overview of the tax conventions in the GTAP model. Next we will discuss the linkages between prices and taxes, and we will finish the presentation by discussing the point of the tax revenue and regional household. So what are the price linkages and what is their role in the multi-region model like GTAP? In the economy, a transaction of any given quantity can take place at different prices. So for instance, producers may face a tax on their use of labor, like social security tax, so that the actual labor costs that they pay are higher than the market wages. Household may enjoy subsidy on food, for instance, if government is subsidizing bread, so the prices that are actually paid by households are lower than the market prices. Another example is for the imported food, for instance, wheat or rice, and it can face an import tax so that the price of this imported food would be higher than the prevailing world market food prices. All these are examples of taxes and subsidies that link the transaction prices to basic prices. Therefore, the price linkages are the system of prices and tax relationships that will be examined in this lecture. There are several tax conventions in the GTAP model that are defined in different ways. On this slide, we will briefly discuss these key tax conventions, and on next slides of this presentation, we will define them in more details. Output tax and factor tax instruments are defined as the ratio of basic to supplier prices. For instance, if we consider social security tax, an example of the factor tax, then the corresponding tax instrument would be defined as the ratio of the social security tax inclusive wage, basic price, to the supplier price, market wage. Domestic tax instruments are defined as the ratio of producers' prices to market prices. An example of the domestic tax instrument is sales tax. Border tax instruments are defined as the ratio of domestic market prices to world market prices. The border tax instrument is an additional layer that is introduced in the multi-regional model such as GTAP compared to the single country model. And this border tax instrument is introduced to represent the differences between world prices and domestic prices on a bilateral basis. Tax instruments are called power of the tax or power of the ad valorem tax. Domestic tax instruments are defined as the ratio of transactions valued at producer prices to the same transaction valued at market prices. Corresponding linkages can be represented with the following formula, where TFD is the power of tax on domestic commodity C purchased by activity A in region R. The corresponding tax can be estimated by the ratio of the domestic intermediate purchases at the producer prices, with DFP, to the value of the domestic intermediate purchases at basic prices, with DFB. These values can be further decomposed into the producer price times quantity purchased of the VDFP value and basic prices times quantity purchased of the VDFB value flow. Further simplifying this expression, we can see that the tax on domestic purchases can be expressed as the ratio of the producer price, PFD, to the basic price, PDS. In a similar manner, we can represent the border tax instruments for the commodity C imported by the destination country D from the source country S. This border tax instrument is called TMS. And it can be represented in the form of the ratio of domestic market price, PMDS, to the world market price, PCIF. Output taxes, TO, and factor income taxes, TINC, are defined as the ratio of basic price to supplier price. In the case of the output tax, the basic price in the model is represented by the PCA variable, and the supplier price is represented by the PS variable. From the income tax, corresponding basic and supplier prices are defined by the PEB and PES respectively. Output taxes, TO, are indexed by commodity, activity, and region, while income taxes are indexed by endowment, activity, and region. Let's look closer into the example of the estimation of an ad valorem tax on output for the commodity C in region R. For this calculation, make B represents the make matrix valued at basic prices and make S the make matrix measured at suppliers' prices. Make matrix represents the value flow of the commodity C produced by activity A in region R. In most cases, one commodity would be produced by exact one activity. For instance, wheat commodity produced by the wheat sector. But this is not always the case, and we can have the same commodity produced by several different activities. For instance, different power generation technologies produce the same commodity, electricity, or one activity can produce multiple commodities, for instance, heat and power cogeneration. In such cases, make matrix would become non-square, otherwise it would be square. PCA represents the basic price of commodity C produced by activity A in region R. This is a tax-inclusive price, and PS represents the supply price. The quantity of the commodity supplied is represented by QCA variable. Then the power of the ad valorem tax on the output of activity A, TO, is defined with the following formula, where the ratio of the make matrix valued at basic prices to the make matrix valued at supplier prices can be decomposed into price and quantity components, and further reduced to the ratio of the basic price, PCA, to the supply price, PS. From the formula that defines TO, we can further explore the linkages between prices and taxes. To represent the commodity price linkages, we can solve the previous formula for the basic price, PCA, and represent the basic price as a supply price, PS, times the power of the output tax, TO. With such representation, TO clearly links the basic price, PCA, and supply price, PS. TO also links make matrices measured in the basic prices, make B, and supply prices, make S. We can also represent the commodity price linkages in the percent change form, where the percent change in the basic price of the commodity C produced by activity A in region R, PCA, equals the sum of the percentage change in the supply price, PS, and change in the power of the output tax, TO. Percentage change variables are represented by the lowercase letters in the model. The discussed output tax linkages present the link between supplier and basic prices, but we can further extend this to a more general linkage convention by also adding the word FOB or CAF prices of exports and imports. On the next slide of this presentation, we will have a closer look into this more general price and tax linkage convention. So how are the corresponding price linkages represented in the GTAP model code, which is implemented in the percentage change form in the model? You can see corresponding equations on this slide. We won't discuss in detail all of these price linkage equations, but if interested, one can find each of these equations in the model code and identify each of the corresponding variables and their definitions. Just to showcase the selected equations, let's look into the linkage between domestic basic prices, PDS, and bilateral FOB prices, PFOB, of commodity C from source region R to destination region D, which is a penultimate equation of the slide. This equation decomposes the FOB, or tax-inclusive, price of exports into the domestic basic price, PDS, and two tax components, source generic tax on exports, TX, which if applied is uniform across all export destinations, and source specific export tax, which can be differentiated across export destinations. In this case, the variable TXS captures changes in the power of bilateral export taxes. However, the presence of a destination generic export tax, shift TX, also permits the user to swap a single export tax shock with another target variable, which is sometimes useful for the model experiments. Similar implementation of the source generic and source specific tax components is also present for the import taxes. The last equation on this slide links the CAF price of imports, PCAF, and FOB price of exports, PFOB, through the cost index for international transportation, PTrans. This linkage takes into account the FOB share in imports at CEF prices, FOB share, and the international transport share in imports at CEF prices, transportation share. FOB share and transportation share add to 1 for the specific commodity C, source S, and destination D. Corresponding price and tax linkages can be also depicted in a graphical form. There is only one set of prices that truly determines all of the other prices. A natural way to think about this is as a price which equilibrates supply and demand in this general equilibrium framework. Thus, we start with the market price of domestically produced commodity, C, in region R, PDS. Working backwards to the suppliers of this commodity, we have the basic commodity and activity specific price, PCA. If each activity produces a unique commodity, like in the classic GTAP model, then PCA equals PDS for the appropriate correspondence between activity A and commodity C. This is also the case when multiple activities produce a common commodity which is perfectly substitutable. The basic commodity and activity specific price, PCA, is equal to the supplier's price, PS, plus a commodity and activity specific tax or subsidy, TO. The supply price, PS, is further aggregated to obtain the unit revenue of activity A in region R, PO. By applying the corresponding taxes on domestic purchases by firms, TFD, households, TPD, government, TGD, and investment, TID, we obtain the corresponding agent prices, which are defined by PFD, PPD, PGD, and PID variables respectively. Separate stream of the price linkages is also implemented for the factor prices with the corresponding pre-tax endowment price PES, post-tax endowment price PEB, and the price paid for factor endowments by firms PFE. On the previous slide, we have discussed the domestic price linkages, so how the domestic price PDS is transformed into the agent price within the domestic market. On these and next slides, we will discuss the linkages between domestic market prices and world market prices, such as export and import prices. Export prices PFOB are obtained by multiplying the domestic price PDS by the corresponding power of the export tax, TXS, where TXS is obtained equals 1 plus export tax rate. This equation converts the domestic supply price to the price of exports, PFOB. And this is price of exports before we apply freight and insurance. On the next step, we add transportation services that link FOB to CF prices as goods are shipped from the source region to the destination region. And thus we obtain the CF price called PCIF. On the next stage, on top of the CIF price, we add region and commodity specific import tax rates, TMS. And this gives us price of imports post import tax, PMDS, of the specific commodity C imported from region S to the region D. In the domestic market, constant elasticity of substitution function aggregates origin-specific imports into their import composite PMS, which is now indexed by commodity and region. So the bilateral import prices are aggregated using this CS function. And this gives us the price of imports that domestic consumers face, called PMS. On the next step, the domestic specific taxes are applied to the imported commodities, so factor taxes, government taxes, consumer taxes, investment taxes, and we derive the corresponding prices paid for imported goods by different agents, such as firms, consumers, government, and investment. These are defined by PFM, PPM, PGM, and PIM variables respectively. The zero profit condition for activity states that the total revenue of the specific activity is equal to the sum of all the input costs and thus all prices of the purchased goods and factor inputs enter the corresponding equation. This includes both domestic and imported prices. With this framework, we summarize the price linkages for both domestic prices and prices of traded commodities, including the cost of transportation services and also import and export specific commodity taxes. One specific oddity regarding the power of the tax that was present in the classic GTAP model but has been changed in the GTAP version 7 is the treatment of the output tax rate. So intuition indicates that the power of the tax greater than 1 implies taxation, and if it's less than 1, then there is a subsidy. Following this logic, the power of the tax equals 1 plus ad valorem rate. So for instance, for the TPD tax, if the ratio of the PPD to PDS equals 1.1, this implies an ad valorem tax of 10%. If the corresponding ratio is 0.9, then this applies an ad valorem subsidy. And in the GTAP version 7 model, this treatment is applied to all variables. So if the power is greater than 1, then it is a tax. If the power of the tax is less than 1, then it is subsidy. However, in the classic GTAP model, the previous version of the GTAP model, this was not the case. And for instance, for their output tax, the value of 1.1 was corresponding to the output subsidy of 10%, while the value below 1, for instance 0.9, was corresponding to the tax. This has been corrected in the latest GTAP version 7 model. Moving to the discussion of the tax revenues and regional household income, one point that should be highlighted is that the tax revenue may change even if tax rates do not change. For instance, let's take TO, which denotes the output tax revenue associated with commodity C in region R, and equals the difference between their make matrix in basic prices, make B, and make matrix in supply prices, make S. We can further rewrite this as a difference between basic price PCA and the supplier price PAs times the quantity QCA. TO will change in any simulation in which there is a change in PCA, PS, or QCA. So even without changing the tax rate, if the quantity has changed or price has changed, then we will have a corresponding change in the tax revenue flow. In general, there is a tax revenue change associated with each agent transaction for which we study the price linkages. And these tax revenues are part of the regional income equation to appropriately capture them in the utility calculations. So to wrap up the lecture on price and tax linkages in the multi-regional model, price linkage equations reflect presence of tax instruments in the model, and they incorporate effects of tax instruments on such variables as prices, tax revenue flows, and ultimately the regional income. These are important equations that also underpin value flows in the model. Thank you for listening to the presentation.